Hey guys, it's time for the Chapter 11 review video. So, number one, oh, by the way, this video is dedicated to Petra because she wanted me to make this for her. Two triangles have equal areas, they are congruent. That is not always the case. You can draw two triangles, one with a height of 6 and a base 8, one with a base of 6 and a height of 8. These triangles are not going to be congruent, but they do have the same area. That's a sometimes case. Second one, if the radius of a circle is tripled, its area is tripled. So let's see, if we have two circles, this one's 3 and this one is 9. 3 squared is 9 pi, 9 squared is 81 pi, okay? And 9 tripled would be 27, it's not 81. This is actually a never. And the last one, the median of a triangle divides the triangle into two triangles of equal area. That is always true. There's no way you can draw a median that will not split the triangle into areas of equal area. Number 4, parallelogram is inscribed in a circle. So anytime a parallelogram is inscribed in a circle, it's going to be a rectangle. Okay, its length is 3 more than twice its width. So we're going to say that this side is 3 plus 2x, twice the width, and 3 more than that. The other side is x. We know that the area of this rectangle is 35. So right away I can say 3 plus 2x times x equals 35. When I distribute, I get 2x squared plus 3x equals 35. So 2x squared plus 3x minus 35 equals 0. Now I can factor. When I factor that problem, I do 2 times 35. This is the Darth Vader method. So that's negative 70. We'll multiply to negative 70 and adds to 3. My answers are 10 and negative 7. So I'm going to split it up. 2x squared plus 3x minus 35. The 3x gets split up into 10x minus 7x. And I factor by grouping, and I end up getting 2x, x plus 5, negative 7, x plus 5. So I have 2x minus 7 and x plus 5. Cannot have a negative 5, so I'm going to get 7 halves, which is 3.5. Okay, and what I just found was my width right here. I can divide the rectangle to use Pythagorean theorem, which I will do. This is 7 halves, and when I plug in 7 halves here, I get 10. So I'm going to do 10 squared plus 7 halves squared equals c squared. Little Pythag. We got 100 plus 49 over 4 equals c. If I get common denominators, I get 400 over 4. So that's 449 over 4 equals c squared. Sorry, it should be squared. I take the square roots of those, and I get square root of 449 divided by 2. Okay, that's the whole diameter. So if I multiply by 1/2 or divide by 2 again, I get the radius is square root of 449 divided by 4. I'm now finding the area of the circle. So if I square this, I get 449 over 16 pi, and that would be my answer for number 4. Moving on to number 5, area of a square is 20 centimeters squared. So to find the area of a square, it's side squared. I know it's 20. Take the square root of 20. I can pull out a 4 and 5. Square root of 4 is 2. So 2 root 5 is my side. Okay, sorry, that is a 5. 2 root 5 is my side. Because I'm finding the perimeter, I can multiply by 4 and get 8 root 5. So perimeter would be 8 root 5. Perimeter is 8 root 5. Because I'm multiplying by 4 since the square has 4 sides. 8 root 5 units is going to be my perimeter. Moving on to number 6. Find a triangle. Area of a triangle is side lengths 7, 24, and 25. So I can do this problem in 2 different ways. First way would be heroes. And second way would be base times height divided by 2. So let's do heroes first. Remember the heroes formula is side semi-perimeter minus the first side, semi-perimeter minus the second, and semi-perimeter minus the third side. So to get the semi-perimeter, I'm going to add 7 plus 24 and 25 divided by 2. So if I add all that divided by 2, I end up getting semi-perimeter is 28. Okay, remember this is my S. So if I plug it in to find the area, I'm going to do 28 times 28 minus 7, one side, 28 minus 24, the second side, and 28 minus 25, the third and last side. Plugging all that in, I get square root of 28 times 21 times 24 multiplied by a 3. Hold on, this should be just 4. Simplifying this a little bit more, I get square root of 7,056, which calculates out to 84 units squared. Okay, the second way of doing this problem would be just base times height. Switch up the colors here. Let's see, we have 7, 24, 25, so realize that will be a right triangle. Doesn't matter which is your base or height, but we know the hypotenuse must be 25, 7 and 24. 7 times 24 divided by 2 calculates out to 84 units squared. So remember the triangle has two different formulas. One is heroes, one is base times height divided by 2. Number 7, find the area of a parallelogram with sides of 9 and 24 and an included angle of 135. So if I draw my parallelogram, does not matter where the 9 and 24 go, not at all. I will say the 24 side will be this one, 9 will be here, and I know the included angle is 135 in between. So what I want to do is draw in my height, because the area formula for a parallelogram is base times height. Drawing it in, this is going to be 90, which means that this is 45 degrees. Okay, so my triangle will look like 24 is my hypotenuse, then this goes 45 degrees, 45 degrees. I know that 24 equals x root 2, so I have to divide by 2 and multiply by a root 2. So I'm going to end up with 12 root 2 and 12 root 2 are my two sides. My base is 9, my height is 12 root 2, and I end up getting 108 root 2 units squared for my final answer, and I'm done. Number 8, find the area of equilateral triangle with altitude length of 10. So if I have an equilateral triangle, I know all sides are the same. I know the altitude is 10. Okay, how will I do this? Well, hopefully you know by now the equilateral triangle, each angle in this triangle is 60 degrees. So when I'm breaking that up, I am getting a 30, 60, 90 degrees. Cross from 60 is 10, so that's equal to my x root 3. If 10 equals x root 3, I solve it. Divide by root 3, multiplied by root 3. Root 3's cancel. I get 10 root 3 over 3 is my x. Now that would be the bottom part right here. That's 10 root 3 over 3. So that's the bottom part here. I'll have to double it. So I'll have to double it, which would be 20 root 3 over 3. That's going to be one side. Again, that's 20 root 3 over 3 would be a whole side. Now I can apply the formula for equilateral triangle, which is side squared root 3 over 4. So area equals side squared root 3 over 4. My side is 20 root 3 over 3. That whole thing squared, root 3 over 4. Looks messy. Okay, let's calculate that out. 20 squared, 400, root 3 squared, 3, and don't forget to square the 3 down there, which is 9. So it's going to look like this. 400, root 3 cancels, just becomes a 3, times 3 over 3, 9, times root 3, divide that whole thing by 4. Okay, I can kind of simplify this a little bit more. I'm going to get 1200 over 3. So 400 over 9 times root 3. I can just multiply that by 1/4. Okay, let's back that up. Let's see. I should have 400 times 3 over 9 root 3 over 4. Looks a little messy, so I'm going to do 1200 divided by 9, and I can get 13 1/3. So another way to do this is 1200 over 9, the root 3 stays, I can multiply that by 1/4. Okay, 300 goes into that, so that simplifies to 100 root 3 over 3 units squared. Another easier way to do it would probably be area of triangle, base times height divided by 2. I know the base is 20 root 3, I know the height is 10, and I can divide by 2. I should get the same answer either way. Next one, the equilateral triangle is 50 root 3. So I know equilateral triangle, all the same side. I know it is 50 root 3, so I can plug that in my formula that I just used in the last problem. Side squared root 3 over 4. Here the root 3's always cancel, multiply by 4. 4 will cancel on this side. 4 times 50, 200. 200 equals side squared. If I take out 100, I end up getting 10 root 2 is my side. Okay, however, I'm not done, because that's just one of my sides. 10 root 2. I still want to try to find the height. So, if I split this up into a 30, 60, 90 triangle, let's move over to this side. This would be 60 degrees. That's my 30, and that would be my height. So, if I split up 10 root 2, 10 root 2, I end up getting 5 root 2 as a side. So this is 5 root 2. Okay, that's my 30 degree. 5 root 2. I'm looking for this one. So if I multiply by root 2, 3, this is my x. Remember, this is x root 3. 5 root 2 root 3 is 5 root 6. And that is my final answer. That's my height. The next one, find the area of a trapezoid. We know the area of a trapezoid is 184. And our trapezoid looks like this. One base is 32, and the height is 8. Okay, I'm looking for the other base, and we know the area is 184. So to calculate area of a trapezoid, 184, 2 bases added together, divide by 2, multiplied by the height, which is 8. I'm going to multiply by 2. 184 times 2. So we have 368 over here, and I'm going to do the 1 plus 32, multiply that by 8, and divide 8 by both sides. And I'm getting 46 equals the 1 plus 32, subtract 32, and my base is 14. Okay, I know this is 14, remember the median is the average of the two, so that's my base 1. To find median, again, I'm going to take the average, 14 plus 32 divided by 2, and I'll have the answer, which is 23. Median is 14 plus 32 divided by 2, 23. Moving on to 11. Alrighty, number 11. Number 11, we have the sides of trapezoid are all congruent. 3 of them are congruent, and the fourth side is 26 less than the square root of one of the other ones. So we have all of them being x, to the isosceles, and then the last one is 26 less than the squared of one of the other sides. We know that the perimeter is 28, so I'm going to add them all up. X squared minus 26 plus x plus x plus x equals 28. When I simplify this, I get x squared plus 3x minus 26 equals 28. Subtract 28, and I have 54. What multiplies to 54 adds to 3. I get x plus 9, x minus 6. Negative 9 will not work, but positive 6 will. 6 is going to be my side, so I plug it back in. And now I know that one base is 6. The other legs are also 6. And what else do I know? I know that plugging in 6 right here, 6 squared minus 26, 36 minus 26 is 10. My other base is 10. Now, finding the height, I'm going to go ahead and figure that out. This is going to be 6. This is going to be 10 minus 6 divided by 2. 4 divided by 2 is 2. So these two pieces are 2 and 2. If I pull out this triangle, if I know that this is 6 and this is 2, it's not going to be a 45, 45, 90 triangle. I will have to do Pythagorean theorem to solve. 2 squared plus x squared equals 6 squared. That's 4 and 36. So I have a 32 here. I can take out a 16. So 16 times 2 would be 4 root 2. Now that would be my height for the trapezoid, 4 root 2. So to get my final answer, I'm going to move down a little bit because I'm running out of room. I'm going to do area of the trapezoid is going to be base 1 plus base 2 times the height divided by 2. So we have 10 plus a 6 times 4 root 2, and I divide that all by 2. Let's see, we have 16 divided by 2 is 8. 8 times 4 is 32. So 32 root 2 is my area. Now I want to find the measure of its largest angle to the nearest degree. So what I'm going to do here, looks like my largest angle in this is right here, the purple one at the top. To figure that out, I'm going to do sine, cosine, tangent. Use trig identities. 6, that's 2. I'm finding that one to be x. So opposites of that angle will be O, that'd be the hypotenuse. I'm going to use sine. Sine of x equals 2 over 6. Inverse. I'm going to get a decimal. What that is, I'll just figure that out. Inverse sine of 2 over 6 is 19.49. Round to the nearest degree is 19 degrees. Okay, if I add 90 degrees to that, I get 109 degrees. Remember, this right here is 19. This tiny angle right here is 19 degrees. I'm looking for the whole thing, so I had to add 90 to it. 109 degrees is going to be my final answer. Moving on to number 12. Find the area of a regular hexagon with perimeter of 72. So hexagon has 6 sides. Anytime I have a hexagon, I know I'm going to have a 30, 60, 90 triangle. If the perimeter is 72, 72 divided by 6, because there's 6 sides, is 12. So each side is now 12. Okay, it's regular, meaning that all sides are congruent. Now I'm going to split up this to find the apothem, because remember the area is apothem times perimeter divided by 2 for a hexagon. To figure out each angle inside this, I'm going to take 360, because I take the whole circle, divided by how many sides there are. There are 6. 360 divided by 6 is 60. Divide that by 2 is 30. And that's going to be this angle right here in the triangle. So again, if I have this angle right here, so I'm going to pull this triangle out. This is 30 degrees. I know the bottom is 6. And make that a little bit darker. This bottom is 6. Then I know the apothem is 6 root 3. So I can say that, again, the area formula, apothem 6 root 3 times the perimeter, which I know is already 72, divided by 2, and my final answer is 216 root 3, and that's units squared. Number 13, find the area to the nearest whole number regular pentagon inscribed in a circle of a radius of 10. So pentagon is inscribed in a circle, so the circle is going to go around it, touching each side. The hexagon, the pentagon has a radius of 10, so there's my 10 right now. So if I take out another triangle, if I pull it out, that's my triangle. This is 10. To get the, again, the amount of degrees this is, I take 360, divide it by 5, which is 72. Divide another time by 2, and I get 36. 36 is my degree that goes right here. This means I have to use my trig identities to get the sides. First one, I'm going to do O and H, opposite in hypotenuse, which is sine. Sine of 36 equals x over 10. For this problem, I multiply by 10. So 10 times sine of 36. And I'm getting 8. 10 times sine of 36 is 8.09. What that is my side down here. Okay, to find the epitome, this side, that would be my adjacent side. So that means I'm going to use cosine. Cosine of 36 equals x over 10. Again, I'm going to multiply by 10. 10 times cosine 36. And I end up getting 5 points. Hold on. This is 8.09. This is 5.887. This is 5.887. Switch these on you. I'm sorry. Okay, so we have the epitome and the side. Okay, remember I'm going to double this, 5.887, and multiply by 5. So I get 58.87 for my perimeter. Okay, and my epitome is 8.09. So solving the problem, 58.87 for perimeter times 8.09 divided by 2. We're rounding to the nearest whole number, so we get approximately 238 units squared. That's approximate, not exact. 14 area of a regular polygon is 196, so it doesn't matter the shape. We don't know if it's a hexagon, a pentagon, but we know that the area formula for a polygon is epitome times perimeter divided by 2. We know that area is 196. The epitome, perimeter, we also know. Perimeter we know is 56. So I'm going to plug that in for the perimeter. And go ahead and solve for the epitome. So 56 divided by 2 is 28. It's 196 equal to epitome times 28. Divide both sides by 28. And I get the epitome of 7. Okay? So, if I do have a shape and its epitome is 7, any shape, let's assume it's a pentagon, its inscribed circle is going to be inside of it right here, and the epitome is the same as the radius. That's the same as the radius, so I can say 7 squared pi to get my area, and my area will end up being 49 pi units squared. Done. Moving on, find the area of a circle with a circumference of 24. So, I know the circumference formula is 2 pi r. I know 24 pi is my circumference. Pi's will cancel, divide by 2, radius equals 12. I want to find the area of the circle. Area is pi r squared, and I know pi times 12 squared is 144 pi, and that is the answer to my problem. I'm finished. Numero 16. Find the area of a rhombus of perimeter of 116 and the longer diagonal is 42. Find also the height of the rhombus. So if I have a rhombus, I know that in a rhombus all sides are congruent. So I take 116 divided by 4 and I get 29. 29 is each side. Remember, in a rhombus the diagonals are going to be perpendicular to each other, so we have a right angle in the middle right there. The longer diagonal is 42. So this one right here is 42. 42 divided by 2 is 21. So each piece will be 21, 21. If I were to pull out this triangle here, I'm going to have a right triangle. So looking at my triangle, I know that one side is 29, that's hypotenuse, the other side is 21. I'm looking for x. I can do Pythagorean theorem. X squared plus 21 squared equals 29 squared. Solve for x. I believe we get 20. So 20 is going to be each side here. Remember, for area of a rhombus, I am going to calculate that by diagonal 1 times diagonal 2 divided by 2. Okay, my first diagonal, the whole thing is 40. Second diagonal, the whole thing is 42. And take half of that, I end up getting my answer, which is 840. So area right now is 840 units squared. How do I get the height? Well, I know the second formula for a rhombus is base times height divided by 2. I'm sorry, just base times height. So moving on, we have an area equals base times height. I know the answer is 840. I know the base is 29. The height I do not know. And I just divide by 29. Both sides, I get the height as 28.97 units. Number 17. Okay, in number 17, because the 90 degree is at the top right here, and we know this angle is bisected, we're going to have a 45, 45, 90 degree triangle with a hypotenuse of 6. Okay, so 6 is going to equal my x root 2. I can divide by 2 and multiply by root 2. 3 root 2 and 3 root 2 are going to be my two sides. Now that I know that this is 3 root 2, this is 3 root 2, and this one is 3 root 2, I have to ask, how am I going to get this bottom length down here? Now, you'll say, good old Pythagoras. We do Pythagorean theorem on that one. So I know this is 3 root 2, this is 3 root 2, like I mentioned, and I'm missing this diagonal, piece of the diagonal right there. So we have a squared plus b squared equals c squared, 3 root 2 squared plus x squared equals 5 root 2 quantity squared. Okay, this is going to end up being 18. 3 squared is 9 times 2, 18. Plus x squared, 5 squared, 25, times 2 is 50. Subtract 18 to both sides, I'm going to get 32. I can take out a 16, so I end up getting 4 root 2. And that's going to be this bottom piece right here. So what I have right now is 3 root 2, 3 root 2. This side's also 3 root 2. And this piece is 4 root 2. So hopefully you agree that the whole diagonal is 7 root 2. 3 plus 4 is 7. So remember my area formula for a kite. Multiply the two diagonals, divide by 2. My first diagonal is 7 root 2. My other one is 3 root 2, and I divide by 2. 21 times 2. Notice how I'm getting 21. 7 times 3, 21. Times by 2. And then I divide by 2. So let me make sure this is right. Hold on a second. This should be a 6. The whole diagonal is not just 3. It is the whole thing here, which is 6. So 6 times 7 times 2 divided by 2, I end up getting 42 units squared. That was a close one. Number 18. For this problem, I do not know that this is bisected. Okay, so I'm going to have to do proportions. Remember that this is a right angle, so if it's hypotenuse to a right triangle theorem, which is 5 over x equals x over 20. Okay, when I'm solving that problem, I end up getting 100 equals x squared, so 10 equals x. 100 equals x squared, take the square root, x equals 10. Okay, 10 is just a piece, so the whole diagonal is 20, and the other one is 25. So we have area. What happened to that problem? 100 equals x squared. So area is diagonal 1 times diagonal 2 divided by 2. First diagonal is 20, second diagonal is 25 divided by 2. 20 again is here, 25 is this whole thing, divided by 2 to get my answer. So I end up getting 250 units squared for my final answer for 18. Looking at the next problem, ABC So this whole angle right here is 120 degrees. Okay, knowing that it's a parallelogram, these two angles are supplementary, so I know this is going to be 60 degrees. Okay, I'm looking for BE. So, because we know it's 60, I know that across from 60 in the 30, 60, 90 triangle is 2x. 12 equals 2x, so x equals 6, which would be down here, and BE would be 6 root 3. Not too shabby. Moving on to number 20, the roof of a two-car garage is made up of two isosceles trapezoids and two congruent isosceles triangles. Okay, so for number 20, I'm going to first take this triangle out, figure out what the height is. So if this is isosceles, I can make the height, and this is going to be 10 and 10. Remember the bottom is 20. Base times height divided by 2 is the area formula for a triangle, and there's two of them. So 20 times, how do I figure out the height? This looks like a 3, 4, 5 triangle. No, it is not. I'm going to do Pythagorean theorem, because this would not be 5. So 10 squared plus x squared equals 15 squared. 225 minus 100 is 125. I could take out a 25, which would be 5 root 3. So 5 root 3 is going to be my, no, 5 root 5 is going to be my height. 5 root 5, and then divide that whole thing by 2. So that's going to be, let's see, 100 root 5. So we have 100 divided by 2, 50 root 5. That could be one of my triangles, okay? So putting them together, the two triangles together is going to be 100 root 5. Okay, that's triangles. Moving on to the trapezoids, I have the side of 10, 24, and I know this is 15. Again, they are isosceles, so I can break it up to make this to also be 10, 24 minus 10, divided by 2, 14 divided by 2, 7 and 7. So each side is going to be 7. I have to get the height again by doing Pythagorean theorem. 7 squared plus x squared equals 15 squared. 49 plus x squared equals 225. Subtract the 49, I get x squared to be 176. I could take out a 16, so it'd be 4 root 11. Okay, so that's going to be my height in this trapezoid. That's the height right here. If you want to figure out the problem, I'm going to use my formula. Base 1 plus base 2. Base 1 is base 2 divided by 2. Don't forget to multiply by the height. So we have a 24 plus a 10, 34, times 4 root 11 divided by 2. I'm running out of room, so I'm going to simplify this. I am getting 136 root 11. Okay, I believe actually that's 68 root 11, but I'm multiplying by 2 because there's two of them. So I get 136 root 11. So the two triangles are going to be 50 root 5. One triangle is 50 root 5, so two triangles okay, the two triangles are going to be 100 root 5. Remember, one triangle is 50 root 5. The two trapezoids will be 136 root 11. Number 1 is 68 root 11. Two of them are 136 root 11. And I know that I have to figure out how many packages will be on this roof. So I'm going to add them both together because we're getting the roof. 100 root 5 plus 136 root 11. In my calculator, calculates out to approximately 674.67. I'm going to divide by 100 because that's how many foot packages will fit in the garage. Approximately 6.7 packages. You can't buy less than you need, so we're going to round up to 7 packages. And that's my final answer. You need over how many packages, or else you cannot shingle the whole roof. Next problem, find the area of the trapezoid for number 21. So we have a 30, 60, 90 triangle right here, so I need to find the height. That's 7, so this is going to be my 2x. X is going to be divided by 2. 3.5, remember 3.5 goes down here. I don't need that though, I need the height, which is 3.5 root 3. So, I'm going to calculate that out by doing area equals base 1 plus base 2 divided by 2 multiplied by the height. Base 1 is 18, the second base is 8, divided by 2, my height is going to be 3.5 root 3. Okay, that is 45.5 root 3, and that's units squared. Okay, you can also leave my answer as a fraction, 91 root 3 over 2, which is the same thing, just in fraction form. Number 22, a square is inscribed in a circle with the area of 136. So we have a circle, we have a square inscribed, and we know the square is circumscribed about another circle. So there's another circle inside that one there. Find the area of the second circle. So we know that the big square is right here, area is 36. I can get that radius easily. 36 pi equals pi r squared. That's the area formula of a circle. I can the pi's cancel, I take the square root, 6 equals the radius. So right now I have a triangle with this being the radius. I'm going to go ahead and draw a triangle here. The right angle goes there. Whole radius is 6, which means that's my hypotenuse. It's a square, so it's always 45, 45, 90 if it's a square. 6 equals x root 2. The easier way is to divide by 2, multiply by root 2. So 3 root 2 and 3 root 2 are going to be my true sides of this triangle right here. Let me highlight it for you. That's going to be this triangle, a little bit bigger. So, because I know that the radius is 3 root 2 of a smaller circle, I can do area equals pi r squared. I know that, again, the radius is 3 root 2. Square it. Square the 3. Square the root 2. That's going to be 18 pi. 18 pi units squared is my final answer. 3 squared, that cancels, so it's 18. The area of a 30-degree sector with a radius of 9. This is just a simple formula. I know that 30 degrees over 360 times pi r squared, and pi r being the 9, is going to be my answer. 30-degree sector just means that this sector is going to be 30 degrees right here. Now the radius is 9. So if you need a visual, there it is. This is going to be 81 over 1/12. 1/12 times 81 pi, 27 pi over 4. You can also have a decimal answer. That would be fine on the test as well. Number 24, find the area of a segment cut off by a chord. So it looks like this. This is what you're finding right now. If we have this being 8, I know that the both radii will be 8. Okay. What I want to do is a triangle. Let me draw a little bit differently. I'm going to want to try to find the height of this triangle. So I'm going to go ahead and draw in my 90-degree perpendicular altitude. Remember, this is 8. I know this is 45, so this is also 45 degrees. If I have a 90 and a 45 in there, the other angle must be 45 degrees. I'm going to go ahead and find the other side. 8 equals x root 2. So divide by 2, multiply by 2, 4 root 2, and the height is also 4 root 2. So there's my height of the triangle. For this segment cut off our chord, I always need to find the area of the sector. Subtract the area of the triangle. So area of the triangle, do that first. The whole half base times height. The whole base is 8. The height is 4 root 2. And don't forget to take half of that. So the area of a triangle is 16 root 2. Sector, 45 degrees over 360 times pi r squared, and r being 8 in this case. So we have the problem looks like 64 and 45 over 360, 8 pi, minus 16 root 2. So that was kind of flat. Moving on to 25. 25, we have this shaded in. It's all this, I believe. Okay. So what we're looking for is the area of the large circle minus area of the smaller circle. And we need the area of the sector there too. Subtract area of that sector, which would be this sector here. Another thing we have to do probably is we need this triangle here that's not shaded, so we'll have to subtract the triangle, add the triangle as well, plus area of this triangle. Okay, so we have the area of the big circle, area of the small circle, subtract area of the sector, add the area of this triangle right here, because we have this tiny piece right here, that must be added back in there because it also is shaded. Okay, this is the shading area right here, so it must be added back in there, like I said. So, area of the big circle. We know that this is 3 and this is also 3, so it's 6 squared pi. Area of the small circle, 3 squared pi. Area of the sector. So, how will we get that? We know that this triangle is, this radius is 3 and 3, which is 6. So this one's also 6. This is going to be 3, which means this side is 3 root 3. You can Pythagorean theorem, or you know the ratio for 30, 60, 90s. Now, if you know that ratio, you know that this has to be 30 degrees. I'm sorry, that has to be 60 degrees. Whoopsie. That is 60 degrees in here. Cross from 60, 3 root 3. And that means this entire triangle has an angle of 120 degrees inside it. So this is going to be 120 degrees. Okay, again, this part right here is done right here, and that's 60 degrees. So, looking at that, we know that's 120 degrees. Area of the sector, 120 over 360, multiplied by pi r squared. Now for the sector, pi r squared, our radius is 6 squared pi. Okay, so area of the sector is 12 pi, so we have right now big circle's 36 pi, little circle's 9 pi. Simplifying this, we end up getting 12 pi. And area of the triangle. So again, here's my triangle here. Okay, in that triangle, I have an entire base of 6 root 3. Remember, because half of it was 3 root 3. That's half. I'm doubling it to get 6 root 3. And I know the height is 3. So we know that's 1/2. Add 1/2 base, which is 6 root 3. Height, which is 3. 18, half of 1/2 is 9. So that's plus 9 root 3. 6 times 3 is 18. Half of that is 9. So 36 minus 9 minus 12 is 15 pi plus a 9 root 3 units squared. Keep that answer just like that. You don't need to plug in the calculator. Moving on to number 26. In this problem, I know each side length is 12. So I'm going to take the area of the triangle, subtract area of 2 sectors, or just a sector. I know that each angle inside equilateral triangle is 60 degrees each side. So I use the formula for equilateral triangle, which is side squared root 3 over 4. My side's 12, so 12 squared root 3 over 4. That's 144 over 4, which is 36 root 3. Sector, now I know that 60 and 60 make 120 degrees. 120 over 360 times pi. Radius, so each side is 12. My radius is 6. Pi squared. So that calculates out to 12 pi. And units squared, that's my answer. I could also think of it as two sectors, one being 60 degrees, another one being 60 degrees. So that's why I'm going to multiply this by 2. In my next example, these are similar triangles because we have corresponding angles congruent. Okay, we also have the reflexive angle here. So what I'm going to do is I know that if you have two sides, A to B, I know that the areas correspond to A squared to B squared. Okay, which means since I know that the area of this small triangle, find the area. Area is 1/2, base, which is 6, height, which is 5. So half of 30 is 15. I know the area of this triangle right here is going to be 15. I also know that the sides are in the ratio of 6 to 9. So 6 over 9, that's my ratio of the sides. Size ratio is 6 to 9. I can simplify it, which is 2 to 3. Okay, I now have to get area ratio, which I get 4 over 9. I know the area of the bigger one's 15, the smaller one's 15, so 15 over the x right there. Okay, if I cross multiply, I end up getting x equals 33.75 units squared. Okay, so remember this is my area, this is sides ratio. If I square them, I get the area ratio. And I already know the area of the smaller one is 15, so to find the larger area, I make that x and I solve. Over here, this is a problem where I have two triangles. I'll teach you the hypotenuse rule. So the 6's overlapped. 6 and 6. X I do not know. 9 I know. Cross multiply. 9x equals 36. X equals 4. Now I know that this side is 4, which makes this side 9. Now when I find the ratios of the two areas, I'm going to do 1/2 base times height over 1/2 base times height. The heights are the same in both triangles. Notice I'm doing CBD, CBD, and ABD, ABD. Okay, heights are both the same, so heights will cancel. 1/2 cancel. The base in CBD is 4. The base in ABD is 5. That's my final answer. Same with this one, we have ABC. So 1/2, the area of base of ABC is 9. The height of it is just the height. And then same with CBD. CBD, 1/2, the base is 4, the height is just height. Those cancel out. So my answer is 9 over 4, which is the ratio of the two areas. Next example is another proportion. 4 over x equals 8 over 6. I can cross multiply, and I end up getting, let's see, 8x equals 24. So x equals 3. ABC, the base of this one is 3. DBC, the base of this one is 6. 3 over 6 simplified is 1/2. On the next one, we have ABD. So the whole ABD here will be 9. BC is 6. BCD is 6. Simplified is 3 over 2. So it's the same idea where I do 1/2 base times height over 1/2 base times height. Remember, the heights are going to cancel, so are the halves, so these are the two bases over each other. The next one, we have similar triangles because we have the angles are the same. This one is the same as this one because the inscribed angle and intercepted arc will be the same thing for both of these. So we have angle-angle similarity here. So, since we have angle-angle similarity, we know that the 5 and the 3 correspond with each other. So we have side to side. So 5 over 3. Because I'm looking for areas of similar triangles, I can square both, and I get 25 over 9. Okay? Next problem, two similar rectangles have areas of 18 and 50. So I know that the areas are 18 over 50. That's a squared to b squared. Now it's easier if I simplify this fraction. I can divide both sides by 2. so I get 9 over 25. Now remember, I want to go A to B because I'm looking for diagonals. So if I take the square root of this, I get 3 over 5, and that would now be my A to B. Okay? So if I have 3 over 5, I can now pick the smaller one, which is 6. Smaller one goes with the smaller side, so this is 3, so 6 has to stay on top because it's smaller, over x. I cross multiply and end up getting 10. 30 equals 3x, divide by 3, x equals 10. That's the length of the larger rectangle. Next one, I have 3 sides, 12, 14, and 6. So what I'm going to do is take Hero's formula. Semiperimeter times semiperimeter minus A, one side, semiperimeter minus B, second side, semiperimeter minus C, third side. So if you add them all up, let's see, we have 12 plus 14 plus 6, that's 32 divided by 2, that's going to be 16, 16 is my semiperimeter. So square root of 16, 16 minus 12, 16 minus 14, and 16 minus 6. So I end up getting 16 times 4 times 2 times 10, 1280. I can take out the 256, looks like 256 times 5. So, and I end up getting 16 root 5 as my final answer. Last one, area quadrilateral ABCD. So we have a 5, 12, 13 triangle. If you did not know the triple, 5, 12, 13, what I could do is I could do Pythagorean theorem. So either you know 5, 12, 13, or, like I said, Pythagorean theorem. 5 squared plus 12 squared equals c squared. Okay? Calculate it out, c equals 13. So, if I know that, I can go ahead and do, again, Hero's formula. Semiperimeter times semiperimeter minus A, semiperimeter minus B, semiperimeter minus C. Add them all up. So I'm going to get semiperimeter 13 plus 10 plus 11 divided by 2. 17 times 17 minus 13, 17 minus 11, and 17 minus 10. 17 times 4 times a 6 times a 7. Square root of all of it. Looks like I get 2,856. That should be simplified to 4 times 714. Which equals 2 square root 714. Okay, that's the area now of this triangle, 2 root 714. And I'm going to add my base times height divided by 2. So this triangle, I can do base times height divided by 2, which is 5 times 12 all over 2. We have 30 for this one. And we have a 2 times 714 for that one. So 30 plus 2 root 714 is going to be my area of the whole thing. If I put in my calculator, I get approximately 83.44 units squared. And that completes this video. Good luck on the test tomorrow. Have a great day.